When using the force-based model, we need to apply forces to the physics components of our entities. We're going to modify the update event of our player prototype so a force is applied each time the W, A, S, and D keys are pressed. To apply a force, simply use the addForce method and pass in a vector representing the magnitude and direction of the force to be applied. For our player, each key press will apply a force in the corresponding direction with a magnitude equal to the player's speed variable. Let's open the entity editor. We're going to change the values of our player's physics components. When we play the scene, we can see a force being applied on each key press, creating a swimming-like motion. If we pause the scene, go back and change the physics components to velocity mode and run the scene again, we can see our player doesn't move since it can't receive forces because it's set to velocity mode. The mass and drag variables are quite powerful and can take some tweaking to get the desired feel. However, this also gives you a lot of flexibility. For example, if we increase the mass and decrease the drag, our smooth swimmer becomes more like a jumpy entity. Another powerful tweak is to apply the force each frame the key is held down instead of once when the key is initially held down. This is a simple function change from key down to key typed. We'll also need to lower the force since it's being applied more often. If we open up the scene again and play, we can see our entity's movement is now closer to that of a spaceship. Now that we know how to apply forces, let's investigate collisions. To demonstrate, I've created a simple wall prototype. It has a physics component on velocity mode so that it won't automatically bounce on a collision. More importantly, it has a collision component. Collisions will only be registered on entities that have this component. You can also freely adjust the hitbox in the editor or in code. If we place a wall and a player in the scene and play, we can see the default collision behavior. When two entities collide, they bounce off each other and apply a force according to their mass and velocity. If we go back to the editor, change the hitbox of the wall and play the scene again, we can see the collisions being registered according to the hitbox, not the entity's position. This can be useful, for example, to simulate an angled camera. In this case, the tops of entities should not register collisions, so we can drag it down a little bit. The next thing we're going to do is define a custom collision for our player. We're going to do this by defining an onCollision method. Inside the method, we check which entity type our player collided with using the generic is function. If the player collided with a wall, then we shrink the player. Let's run the scene again, and we can see our player get smaller each time it collides.